Okay, so today I'm going to talk about diffusion, osmosis, and tonicity because it's kind of confusing at some parts. So we all know diffusion is the tendency for molecules to spread out evenly into the available space. It goes from high to low concentration, doesn't take energy, blah blah blah. And osmosis is a diffusion of water, and here you can see that it's diffusing and it diffuses until it reaches equilibrium, which means the water molecules move at the same rate and the concentrations don't change. Substances diffuse down their concentration gradients, which means that they, again, diffuse from high to low concentration, and that's called passive transport because it uses no energy. And like I said, osmosis is the diffusion of water. Across the selectively permeable membrane, here's just an example of that. Again, they just try to balance out the concentrations. You can see in the YouTube, the lower concentration of water goes to the higher concentration of water to balance out the concentrations. So even though I said it goes from high to low, the water goes from low to high because there's a higher concentration of water here than here. So the water goes from high to low, but the solute goes from low to high. So yeah. And that's important, just don't get it mixed up. The water goes from low concentration of solid to high concentration of solid to balance out the concentrations. Okay, tonicity is the ability of a surrounding solution to cause the cell to gain or lose water. In an isotonic solution, the concentration inside the cell and outside the cell is made the same, so nothing diffuses, there's no net movement of water. In a hypertonic solution, the solute concentration is greater outside the cell than inside the cell, so the cell loses water, and I'll go over that in just 1 second. And in a hypotonic solution, the solute concentration is less on the outside, so the cell gains water. And let me just explain in different ways. So let me start with the animal cell. So in an isotonic solution in an animal cell, water goes in and out and the water is normal and healthy. In a hypotonic solution, so outside, let me draw a picture. So this is the cell. Outside, let's say it's 0.9 molar, and inside it's 0.2 molar. I'm going to do a hypertonic solution. So this is hypertonic because outside is greater than inside. The water will flow from inside the cell outside so it can balance out the um, concentrations because there's more water inside the cell than outside. So it goes from low to high solute or low to high concentration. And so because of that, the cell shrivels up and it's a sad little piece of poop. And then this exact opposite things in hypertonic solution. So let's say that inside the cell is 0.9 and outside is 0.2, so it's less on the outside, so it's hypertonic. So there's more water on the outside than the inside because the solute concentration is greater than the inside. So water would flow in and the cell would stretch until it burst, which is called lysed. And for animal cells, they want to be normal because they want an equal exchange. And the same exact thing happens with plant cells, except the fact that plant cells, they want a hypertonic solution because they have a cell wall. So to give them the shape, they need to have pressure from the inside and they need to be as full as possible. And if they're put in a hypertonic solution, water will just keep on coming in. If they're put in an isotonic, it'll be flaccid and weak. And if they put it in a hypertonic, it'll be like really, really sad and like basically a squishy ball thing. So that's all bad. And again, we went over turgid and flaccid, and there's make sure you know the vocab. I mean, a plant cell in a hypotonic solution as it is turgid because it's firm. When it's limp, it's flaccid. In a hypertonic environment, the plant membrane like pulls in on the wall, as you can see, because it's losing so much water that the membrane's pulling in on the wall, and that's called plasmolysis, and then that's it. And then